All right, hi, welcome everybody. Thanks for coming uh, to Demystifying TLS certificates. Let's get started. So a little bit about me. I started launch school in October 2020. That's when I started with Core. Was transitioning from a previous career as a musician and music therapist, and was at that time a stay-at-home dad, but had dabbled a little bit in computer science in college. So got back into it in 2020. So I was part of the 2020-01 capstone cohort. Um, so January of 2022. And then I started working for Intuitive Surgical in July of 2022. And so there I work with a variety of technologies. My main languages are Go and TypeScript. But my job has actually, I work on kind of an interesting product where we ship a VM. And so I've had to learn a lot about virtualization, TLS and certs, Linux fundamentals, TCP and HTTP at more a foundational level to get certain things to work. So that kind of inspired me to do this talk um, about TLS because I came out of core feeling like I had a really good grasp on TLS, and I did at a high level. Um, and then I remember in capstone, um, the like there was some part where we might have had to provision TLS certificates, and it still felt really scary. Like I didn't really understand. I knew in general what they were, um, but I didn't really get how. Okay, what does that mean to get a certificate? How do I get it assigned? I had gone through um, something to set up my own virtual server, and there's this magical thing called certbot, and you ran a couple commands, and it got you a certificate. And so in my job, turned out I had to dive really deep into this, and I thought, oh, this is actually not so scary. So um, let me talk about the goals of this presentation. So I hope that you reinforce and deepen your understanding of TLS. I really liked all going through caps, or really all core and capstone, to like understand just a little bit about like one layer of abstraction deeper than I really was studying. And that helped me, I feel like, kind of get what was happening at the layer that I was really trying to master. And I want to show that TLS certs are not something like mystical handed down from on high. You learn about these certificate authorities, and they sound um, like these kind of entities that just grant you the certificate, and they are, but we're actually going to make our own certificate authority today. And so you'll see that it's not actually the technology part of it is not that crazy. It's all of the other things surrounding how secure those certificate authorities need to be is kind of what makes them seem like this other thing that I didn't understand. And then once I started playing with the actual technology, I did. And then I want to just demonstrate some of the tools that let you explore certs on your own, because it's actually very easy to like really look at certs. You're not going to understand everything right away, but at least if you have the tools, you can kind of dive into them. Some things this talk is not. I'll not be teaching you how to use TLS for anything real. So we're going to look at self-signed certificate authority and certs, and um, there are cases where sometimes you want to use your own certificate authority or self-signed certs, but don't go and implement this in your job or even at home and say, oh, well, Josh taught me how to do that. That's not what this is for. You're going to have to do some more research on that. Um, I'm not suggesting you need to master any of this. Even if you don't understand everything, hopefully this just gives you a peek at what is really happening. And then also, I just want to make the disclaimer, I don't consider myself an expert on TLS yet. I've learned a lot. I have a lot more to learn in terms of, there's so much in terms of the intricacies and even the mathematics behind encryption. So we're going to talk for a little bit, and then we'll actually go on the command line. And I was just telling Surgeon before this that apparently the Scratch directory that I had been working on before was in my temp directory and got deleted. So I was furiously recreating some things, and you might see a little live debugging, which is always exciting. So why do we need TLS? Hopefully we all know this. It's really three things: confidentiality, so others can't read my communications with somebody else. Um, Authenticity, so I know who I'm communicating with, so I can authenticate that this entity or this person is who they say they are. And usually that's a server that I want to make sure that I'm connecting to google.com and not some site that's going to give me malware. And then integrity, I want to know that the content that I'm getting has not been tampered with. So those three things are what TLS gives us. And really, uh, encryption and public key encryption infrastructure gives us. So very quick review of the TLS handshake. I'm assuming you mostly know this, and this is actually leaving out a whole lot. So we know that a connection between a client and a server is established with a TCP handshake, and then the client sends a client hello. This is for the TLS, right? The TLS hello. Then the server sends a server hello, which includes the server certificate. Now, this is the important part today. The client authenticates the server certificate against root CA certificates, right? So you've probably learned about the chain of trust and how that's how we establish that a certificate that we're going to trust a certificate. And then not the focus today. There's a bunch I skipped over here, but if the client can authenticate the server certificate, the client and server use an agreed upon algorithm to create a symmetric key for the rest of the TLS session. I think this is really interesting. The certificates and all of this stuff around the certificates is only used to establish a connection. That's all it does. Um, the asymmetric private and public key pairs are actually really inefficient to encrypt anything with. And it's much more efficient to both have the same key. Both the client and the server has the same key. And so we use that these certificates to establish the same key securely so that then the rest of the session, we can just keep using that key. But without the public and private key pair and all of the infrastructure surrounding the certificates, there would be no way for you to connect to a server that you hadn't connected to before and trust that it's the right server, and also establish a shared secret without somebody else spying on you, really. Okay, so this is a concept that I think is really, really important: encrypting versus signing. Um, they're kind of the same mathematically, kind of the same thing. You're encrypting something, you're running something through this encryption algorithm, um, and generating an output, but the the uses for this are different. So let's look at this. Encryption, your goal is to make something secret, right? So when you encrypt something, at least using a key pair, a public and private key pair, you're using the public key of the recipient, right? And so let's think about for a second what that means. That public key, if you encrypt something with the public key, it means only the person with the private key can decrypt it, right? So what this does, it prevents anyone but the recipient from decrypting this key. And so what this gives you, if we go back to those three things that TLS gives us, this does give you privacy. You know that only the person with that private key can decrypt this. But in terms of the message, that person can't guarantee where this message that you've encrypted comes from. There's no integrity. Anybody who has the public key can send any message they want. They can encrypt any message they want for that recipient. And it doesn't give any guarantees about who it came from. All that guarantees is that the recipient, the person with the private key or the server with that private key, is the only one who can read a message. Now, on the flip side, you can sign something. And this uses the private key of the sender. So if I want to sign something, I'm going to use my private key. And what this means is that it can be decrypted with my public key. Now, my public key is just that. It's public. Anybody can have it, right? It's not a secret. So that means if I encrypt something with my private key, it's not secret, right? I'm not doing this to make something secure and secret. What I'm doing is you can know if I send you a message, you can be sure that this message must have come from me, assuming that I'm the only one with this private key, right? And you can also guarantee that this message hasn't been tampered with, because as long as you know and you trust that my public key really belongs to me, that I actually control that private key, the of the key pair, then you're sure that this message that you've decrypted with my public key came from me and that nobody else messed with it. So it doesn't give me any privacy. I would have to encrypt something with a public key to get that. But it does give this authenticity, it came from me, and it gives integrity. So you know that that wasn't messed with by anybody else. So any questions? I think this is important there. If you've got any questions, um, because this is really important to get. All right. If there's no questions, feel free to jump in at some point if you're not following. So we're going to go over to the terminal, and here's some goals. We're going to actually look at some certificates. We're going to actually make our own certificate authority. We're going to sign a certificate using that certificate authority. We're going to use that certificate in a simple little web server, and then we're going to get our browser to trust the certificate. So let me get set up here real quick. Just a moment. All right, let's clear all that mess. All right, so the first thing we want to do is we want to actually look at a real certificate and see what's in there. So there's an open source project that really underpins a lot of TLS on the web. And it's OpenSSL. And so there's a command line utility. I believe it's also just a library that's used in most implementations of TLS. There may be some other implementations that people use, but this is the one you're going to see probably the most. So OpenSSL is included on most distributions of Linux, on Mac. I don't know about Windows, but you find it in a lot of places. So trying to get back to my list of commands on my other screen. All right, so the first thing we want to do is we're actually going to use OpenSSL has a lot of subcommands, and one of them is sclient, which is kind of this client you can go out and make connections to other servers and examine their certificates. So we're going to use this show certs, and the server we want to connect to with, let's do google.com. All right, and it's going to spit out a whole bunch of stuff. So let's go back up here, and this looks really scary, okay? But it's actually, if we break it down a little bit, it's not that scary. So you see this just says we connected. Depth 2, so remember you probably learned about cert chains, right? So there are different chains in the cert. So here we have one at depth 2, that's Google Trust Services. At depth 1, that's also Google Trust Services. And then at depth 0 is star.google.com. So when we connected to google.com, it's sending a cert that is good for any subdomain of google.com, right? And then it's also saying, oh, hey, I've got these other two in this chain, right? So, well, let's go in a little bit more detail. So now we see the certificate chain. Here's that, sometimes it's called the leaf cert. All right, so the S, this stands for subject, right? And the CN is, I believe, common name. This is actually not used very often anymore, but it's usually still put in the certificate, but it's been superseded by something a little better. So this is the name. And so this is what your browser is going to check. One of the first things it's going to check, actually, I don't know what order it does it in, but one of the most important checks is to say, hey, does this name that I connected to, because your browser obviously knows what you typed in the search bar or what link you clicked, does the URL, does the host name match this search, right? And if it doesn't, it's going to say, hey, this is not good. So the subject is really important. And then this I is for the issuer. And so you'll see the organization, that's what O stands for, is Google Trust Services. And the CN is this thing, GTSCA 1C3. So that's actually, I think I figured out, Google Trust Services Certificate Authority, and it's got some identifier of that certificate authority. You see there's some other stuff about the actual keys. We're not going to get into that today. And then the expiration, right? You get a start date and an end date. And so actually there's a lot, it seems like every year there's a few outages that happen because some cert expired, right? And actually certificate rotation is a huge headache, and something that most places try to automate, but automating it well can be really difficult. So we've got this cert for google.com. This a certificate authority signed the cert. Okay, well, why should we trust that certificate authority, right? So this, by the way, this is just the encoded certificate, right? That's all it is. This is this encoded certificate. It's got a lot of different things. We'll actually look at one of these a little bit more in depth in a minute. So then here now we have a second cert. The subject is that same certificate authority we had. And look, the issuer is another certificate authority, Google Trust Services root R1, right? So this is some root CA for Google Trust Services, but it keeps going. And now we have the certificate for that. And here is the global sign root CA, right? So global sign root CA, and then it ends, right? And so we see some more information that it gave us. Okay, so we have this global sign root CA, and how now, but there's no more certificates in this chain. How do we actually trust this? Why do we trust this? Well, the answer is that you don't unless you or somebody tells your browser or your operating system to trust it, right? And how does it do that? Well, every operating system has a directory where it keeps all the certs. And so in my Ubuntu-based distribution here, we have this whole list of all these certs, okay? Some of these are actually symlinks to other ones. I'm not actually entirely sure. Obviously some sort of hash. I don't know why that is, but let's go back up. We were looking for this one, global sign root CA. So let's just find that global sign root CA. Oh, well, there's a bunch of them, right? Here we go. This looks interesting. So let's look at that. All right, we have the certificate and it's a bunch of gobbledygook, right? So how do I actually make sense of this? Well, we go back to OpenSSL, and this is an X509 certificate. That's what TLS certificates are. That's just the name of the standard that established this format for certificates. And actually, one of the reasons you'll see some of the information that was in here is that they thought this was going to be kind of like a directory, almost like a phone book. And so that's why you'll see later it actually asks us for questions like our state and our country and our organization and our organizational unit. it was kind of intended for that, but then the use that ended up sticking was these TLS certificates. So we want to see, we don't actually want it to output in a different format. We want to see the text, and we're going to use this global sign rootca.pem. Okay. So again, this is going to that goal of like showing you the tools where you can see, kind of answer some of your own questions about certificates. Now this stuff, this is really intimidating at first. Like, how do I remember all of that? And the fact is, some of these I do remember, others I don't. And I look up every time. And the more I have to do this, the more I remember. But hopefully this just makes it so that it's not quite so scary. So OpenSSL took all of this up here, right? And it said, let me give this to you. Let me decode this essentially, because this is there are encrypted parts of this data, right? But it's not, you would think, look at this and think, oh, this is encrypted. No, it's just encoded in a way that we can't read, right? But it's not encrypted. It's just hard for humans to read. So we see some of the same information here. I want you to look at this here though. The subject of this certificate is global sign NVSA root CA, and then the CN is the global sign root CA. That's the subject. So that's who this certificate is saying. This is the the not the person, the server, or in this case, the CA that this certificate is saying is valid. I'm gonna need a drink of water here. So let's think for a second about what a certificate really does. We talked before about how you have a private and a public key. All a certificate really does is say it takes a public key, right? Because I could just give you my public key. I could just put my public key out there, but that doesn't stop somebody from saying, oh no, this is really Josh's public key, and give you something else. And now they're going to be able to impersonate me. So I want some way of saying, in a tamper-proof way, this public key belongs to me. In this case, global sign root CA is saying this public key here, right, belongs to them, belongs to this root CA, right? And the way they do that is they get an issuer to sign this public key plus this metadata in a certificate. And once it's signed, because remember, we looked at the difference between signing and encryption. Once it's signed, you can't tamper with it. And so if it's signed by a CA that I trust, then I'm going to trust that. That I'm going to trust that this public key right here actually belongs to this entity, and I can trust that anything that's encrypted, anything that is signed by this private key that I can decrypt with this public key, I'm going to trust that it came from them. But I want you to notice something. Probably some of you have already noticed. Who's the issuer? Well, that's this global sign root CA. It's the same issuer. So here we have a self-signed certificate authority certificate. And why should we trust that? Well, you probably learned in the networking course that there are, a handful of these root CAs that basically a bunch of organizations get together and make sure they're secure. And there's all sorts of things. I don't remember if this was something in launch school that I read, if it was linked to launch school, but or if it was something I read another time. But basically, there's the private keys are stored on hardware modules that are tamper-proof and can only be accessed if, like, it's kind of like the movies where two people have to put in the key and turn it at the exact same time. I mean, it's not literally that, but it's kind of, there's a whole protocol so that these keys the private key can't be tampered with. And so because all of these entities are involved in making that secure, we say that we trust it, and so our OS installs it. Our browsers come shipped with these certificates of these places that we say we all trust. Now look at this too. This is good for 20 years. A lot of times it's good practice to have certificates that are good for a shorter period of time, because then if they did get compromised, then there's a shorter time where somebody could use it. Um, but that's how well protected these root CAs need to be, that they trust that this is going to be, actually, I'm sorry, 30 years. I did my math wrong. Um, 30 years that this CA is good for. So you can bet in January of 2028, we're going to be hearing about what's going to happen when this, like, old computers that still have the certificate installed are going to start not trusting certain certificates that are signed by this. All right, so we have looked at the certificates. I actually can't see the chat, so I can't see if there's any questions, but this may be a good time. I'll come back over here. Yes, it looks like there is. So the signature is created by the private key of the sender, and the receiver uses the public key of the sender to decrypt the signature against the raw message. Yes, yes, exactly. And I didn't go into good detail about that, but essentially the signature, and actually right here, here's the signature. Thanks for bringing that up. This is the signature, and the signer uses their private key to basically take all of this information up here, the public key and all of this metadata, the subject and the validity and all that, and they sign it all. And now we have both the plain text version of this and this signed version. Because I have the public key, I can decrypt that signed version. And as long as I can decrypt it with that public key, I know it came from that sender. So yeah, that's a great Mehdi. That's exactly right. Any other questions?
Yeah, we have a question in Q&A. Rakesh
Oh, okay.
asks, is confidentiality same as privacy here?
Sorry, could you repeat that?
Yeah, is confidentiality same as privacy here?
Yes, yes. I think I might have used those terms interchangeably. So um, I think in that sense, there may be some differences in terms of, in a cybersecurity sense. I'm not a cybersecurity expert, but essentially all I meant in in using those terms is that, like, other people can't see what I'm sending, or decrypt that unless you have the correct key. All right. So let's go back to this here, and we're going to make our own CA. And this is the part where it really started clicking for me after I did this a couple times, that, like, oh, that's all this is. It's not actually that hard. So we're going to, again, use our friend OpenSSL. Oops, sorry. And gen RSA. RSA is the type of key. I'm actually going to get rid of this part. That would be if I want normally you would want a password on your private key. I'm not going to put it on there because I don't feel like typing it a bunch for now. So we're telling it, generate an RSA key. This is how many bits it should be. And then this is the output file. And it does some stuff for a minute. And now if we see, we have our root CA key, right? Well, great. What do we do with that key? Well, I need a certificate and I need to sign it myself, right? So we're going to use this command here. So now we've got another subcommand. We're making a request for an X509, which you can kind of just fill in TLS certificate, right? It's going to be a new one. We don't want the password. here's the key we're going to use. Um, this is the algorithm to use. Here's how many days, and here's the output file. So you can see, even though all this looks kind of scary and it's hard to remember, it's not, if you just go line by line, it's not that hard to kind of figure out what it's doing. Okay, so this is where the thing I was talking about, where this was originally designed for like a kind of a phone book idea, or a registry, or directory, I guess is the word I'm looking for. It all these certificates actually have all of this information in here. So I'm in the state of Michigan. You actually don't have to put any of them, but I like to represent, from Kalamazoo here. I'm gonna say this is Josh's demo CA. I'm not gonna put in a unit, but I am gonna put this in. If you put one thing into a certificate, probably the common name, even though, like I said, it was kind of deprecated, it's not used as much anymore, it's still usually put in there. I'm not going to put in an email address. And now let's look at the search. So there it is. Now, if I use this same OpenSSL, and I look at this root CA search, it's going to look exactly the same, pretty much, as that root cert from a legit CA. It is the same mathematically, right? My subject is all that information I just put in there. Josh's demo CA. Whoops. For some reason, things jump around after I unselect. So I'll try not to do that. And the issuer is the same thing, right? Here it shows my public key. You might be saying, hey, I didn't see you output a public key, but the public key is actually like it's like integrated with that private key. So you can, if you have the private key, you can generate the public key, but not vice versa. So here's that public key. This is the key that we generated in the first step. And then the signature. You notice here we have some extra stuff. So some subject key identifier. This is like the fingerprint of the key. And then basic constraints, CA true. We're going to see this come back up again, this kind of thing. You can add on extra information, say this key should be able to be used for this, or not used for this, things like that. And so we'll actually see where that comes up if we get that far today. So great, we have our CA. What do we do with this, right? Well, let's sign some certificates. So if anybody has used CertBot or any sort of other like automated TLS certificate generator or tool, it's probably doing something like this in the background. What we want to do is we're going to, once again, use OpenSSL. So I'll make it clear here. And we're going to generate another key. Normally, you would not be doing this right on the same computer where you've got your CA. Your CA, a lot of times, even if you do generate your own CA, you probably really want to protect that key, because if you're going to be trusting certs from your own CA, you want to be sure that somebody else can't get a hold of that and spoof one of your servers or something like that. So I'm going to make a key that I'm going to have for localhost, right? So we're going to generate the key just like before. There it is. We can see that key. It's this private key. We can we could look into more information. This doesn't really have, this is just a big, long random number, essentially. Or actually, I think it's technically like two really big prime numbers combined mathematically. We don't have to go into the mathematics of that. But now I have this key. Let's say this is on my server, right? What do I do now? Well, I need to generate a what's called a certificate signing request. So what this does is this tells the CA, it's something I'm going to send to the CA that says, hey, please sign this certificate with this metadata and this public key. But that authority has to be sure that I'm controlling the private key, because then otherwise, anybody, surgeon could come in here and take my public key because it's public. I can give it out to anybody. And he could say, hey, certificate authority, sign this. And he could put up a spoof website or a malware website in my name with my public key. So I have to sign this with my key as well. So what we're going to do here is, again, use OpenSSL, and we're going to make a request. It's a new one. You saw some of this before. The key this time is going to be the localhost key, and we're going to make this, the output is actually a certificate signing request, a CSR. And then we have some of the same things, just like when we made I won't put all this in this time, but I am going to put this common name in because I want this to be associated with localhost, because later we're going to use it locally here. I'm not putting a password in. And then we can see this CSR. And it's just going to actually look the same. It's all encoded. We won't go into exactly this because it's not as interesting. We'll actually see the certificate. All right. So getting the certificate, and this is where my files actually got messed up. So you might have to bear with me if I mess up this command for a moment. We're going to take, I want to show you a couple files actually. So I've got a couple files here that have a little bit of extra data. It's actually looks like a lot of extra data. Most of this is just comes from OpenSSL itself. But let's look at the bottom because this is the part that I added. Right here, this subject alt name, DNS localhost. So remember how I said the common name, the CN, is kind of being deprecated. There's a bunch of reasons for that I don't fully understand myself, but this is kind of the alternative. You can actually list a lot of DNS names on one certificate. So you can list many. You can list an IP address, although not for a public certificate from like a public authority. You couldn't do that, but let's say you wanted to put a certificate on your own network, you could do that. So this is kind of like the new CN. So that's this extra file that I'm going to refer to here in a moment. So let's hope for the best here. So again, I'm going to make a request. I'm going to tell it the algorithm to use. I'm going to tell it the key should be, oh, yep, the key. I apologize. I'm looking at this, and we're gonna overwrite that certificate signing request. In the interest of time, I'm not going to show you what happens if you don't include that alternative name. I forgot to include that here. So we're going to use the localhost key. For the subject, we'll go through that again in a moment. We're going to do an extension with that subject alternative name, and the config is going to be the CSR.extensions. And then we're going to go out to the localhost.csr. I think this is going to ask us the same things. We'll put a bunch of stuff in. Okay, now we've got the CSR that we can use. Sorry about that. So now we need to generate the certificate. That CSR is actually the thing. Let's actually take a look at it. I said we weren't going to look at it, but let's take a look at it because it's interesting. This is what you would generate on your server. You've signed it with your private key. Um, and you're going to send it to the the certificate authority. So it kind of looks like a certificate a little bit, but notice it doesn't have an issuer, right? So I have my subject. This is this is the thing it puts in automatically. Um, my CN is localhost, right? Here's the key. I'm saying here's my key. I want you to also add this DNS, this localhost for a subject alternative name, and I've signed it with my private key. So now you would send this off. You're not sending your private key anywhere. It's just your public key and that metadata, and the certificate authority can sign it. Now, typically, you would, if I, for instance, if I have joshkeller.dev, how does that certificate authority know that I have joshkeller.dev? Well, usually I have to prove it in some way. The most common way is that you um, can, sometimes it's like you can serve something from joshkeller.dev. You can put a DNS record in the zone file for that, and that proves that you're in control of that domain name. So there's a bunch of ways that you can prove that you're in control of that domain, and then they'll grant you that certificate. So we are going to create this, and we want to use, we're going to take in the localhost CSR, right? Because now we're going to act as the certificate authority. We're going to use my root CA certificate, and then we need to use the key, because remember, we're going to sign this with the root CA key. So we need to sign that with the root CA. And then we can do some different things here. So I'm also going to use an extension file here. And I'll show you what's in that in a moment. Actually, we're not going to use it because I can't remember, and I don't want to. I'll show you what happens when we don't use this at the moment. So we've got the CA key. We're going to, we need to tell it how many days. Notice up here, this doesn't say anything about how many days. So the certificate authority is in control of how many days something's available for. So let's just say 300. We're going to use this algorithm, and we're going to tell it to output to localhost.search. Okay. All right. Let's take a look at that for a second and see what that looks like. I think you ask yourself what you expect in terms of what the subject is going to be and what the issuer is going to be, and if you have any questions about what you're going to see. So the localhost search. So we have my subject is localhost, right? And my issuer is Josh's demo CA. So we did it, right? This is our own CA that we created. We self-signed the certificate, and now we've created a key. We've created a certificate signing request, and we actually signed a certificate using that CA. And you can see all of the stuff that we wanted to be part of it. Now, you'll notice actually we're missing something. Remember that subject alternative name? This is what I was going to get from that extension file. That's missing. And that was included on my request, but the CA didn't actually do that. So we're going to go back and regenerate this real quick. I'm going to remember to look at the other file here. There we go. So I'll show you what's in this. This is a couple extensions, and I need to actually include that when I sign the certificate, and then this is another one. But let's try to use this key first, and then we'll come back and regenerate this in a moment. Um, so I guess a good place to just see if there's any questions. I don't think I can see the QA. So, but put them in chat or whatever you like. There's not. All right. All right. So if you're still with me here, I know this has been a lot of command line, but I think I actually always appreciate like seeing somebody talk through what they do. I've had a lot of success like seeing somebody demonstrate this, demonstrate things on the command line, and then it was like, oh, that's not so hard.
We have a question in Q&A
Ah,
from
yes.
Chase, who asked, what did no out mean? So it was dash no.
So yeah, no out. Actually, I think the best way to answer this is if we go back and look at, so this command where we actually generated um, the certificate, see how it has out, and I'm giving it the file that I want it to output to. All that no out means is that I'm not outputting to a file. And then that's why I think that actually we can, you know what, let's experiment for a second. If I said out and cert.text, so it just meant I don't want you to output to a file. I just want you to output to the standard out, to the terminal. But here I did the exact same command and I had out and I gave it a file name and it output to that. So that's what no out means. Thanks for asking that. Yeah. So, all right, let's go back over here and I'm going to show you a little bit of code. Even if you're a Ruby student, hopefully you can understand this. Some imports. We're going to load up the private key and the certificate. That's all this is doing. And we're going to bundle them in something called credentials. Express is just the web server, JavaScript web server. It's kind of like Sinatra or Rails a little bit. It's a framework for making web services. But because we want HTTPS, we need an HTTPS server. And so you'll notice we just pass in these credentials, which is the key and the certificate. The server needs both of those, right? Because it's going to send the certificate, but it also needs to sign things with that private key. And then the app is just saying, hey, HTTPS server, when you get this thing, you need to, once you can make a connection, send that connection on to the app. We're going to use cores, and actually, here's the thing I forgot to put back in, is server.listen, of course, and I think we can just put, let's listen on 8443. All right, now if everything works well, node index.ngs. You know what? Let's go back in there real quick. And just for sanity's sake, okay, so now I've got this thing listening. So over here, I'm going to do this on, if you're not familiar, curl is just a way to make HTTP requests from the command line. And I'm going to connect to localhost 8443 and try that. Aha. Let's read this command or this error. Curl failed to verify the legitimacy of the server and therefore could not establish a secure connection to it. To learn more, blah, blah, blah. So unable to get local issuer certificate. kind of a side note, I have seen this error more times than I can count in my job because my company uses a corporate proxy. So traffic, when it's going out, it goes through a proxy that actually terminates the TLS, examines, does whatever security scanning, and then makes another TLS request. So my TLS session is actually with my proxy. And some tools say, wait a minute, I don't trust that certificate. They've installed, the IT has installed that certificate on my system, but some tools don't know where to look for it. So I've seen this so many times. I hate this with a burning passion, and yet I've also learned a lot because of it. Because now I'm not scared of uh, that error anymore. I know what it means. I just know that it's going to mean some looking in the docs to see how to get that particular tool to trust these certificates. But now you also know what it means. It means for some reason it's not trusting the certificate. Well, let's take a better look here at this. The -V is just for verbose output. Now we see a lot. So it's trying to connect. We have a TLS. So remember we talked about that handshake, client hello, there's certificate status. So that means it sent back the certificate, this with the server hello. There's a bunch of other steps. And then we see this, unknown CA. So for some reason, curl doesn't like Josh's demo CA, right? It doesn't trust it. Well, it's very easy to get curl to actually trust it. If I can remember. Yeah, so we're just going to say, hey, curl, trust this cert. And now let's see if this works. Did not work. Like I said, you might see some live debugging. Oh, I'm sorry, because I used the wrong flag. We need the CA cert. The path just gives a directory to look in for any cert. So if you have a lot of them that you want to trust, so we need a CA cert. We're going to trust it. And now we see the message from my server. And if we get back and look at the verbose output here, we see this time this looks a little bit better, right? We actually got through the whole handshake. There's the whole changing the cipher, and then finally you're finished, right? And then it actually gives you the information about our certificate. And look there, it's that localhost certificate issued by Josh's demo CA. And we did it. We established a TLS session from the command line, granted, to our demo CA. So what happens if we go into Chrome? Let's see. Localhost 8443. I don't know how many of you seen this before, but this is the thing you probably shouldn't ever actually do, but I'm going to because I know what I've actually connected to. Now, so I connect and I can actually see that, but I see this up here. I can come look at the certificate and I can see, oh, I see. This is all the same information that we saw in the command line, but for some reason, this doesn't trust that. So how do we get the browser to trust that? Well, we can come up here and we can go, if I remember right, settings, privacy and security. Now this is well into the part. Remember when I said what this is not? I'm not recommending you do this, right? So don't go and start trusting a bunch of certificates, but you can. And now that you know it exists, but I think knowing how this all works helps you understand when you're writing code and when you're designing systems. So you have your certificates. At first, I actually put the certificate in there, and that's not where it goes. These are client certificates, which is mutual TLS, and that's a whole other tech talk. You have servers, and now we have authorities. Oh, this is from when I was demoing. Interesting. So when I was coming up with this, I had another Josh's self-signed CA, and I trusted it. But let's import that and let's go to home. We'll find that. Here's my root CA cert. And I want to trust this for identifying websites. Look, you can also, there's TLS on email, or actually, I don't know if it's TLS, but, or you can trust this for identifying software makers. So software makers need to sign their software so you know that you're not getting malware instead of theirs. And so you can decide if you want this to trust that. So I'll just trust it for identifying websites for now. Now, this isn't going to work, but let's go back and try this. It's still saying it's insecure. And this, if you're still with me, this goes back to that other part that I was starting to get into where, let's go back to that when we signed the request. Here we go. We need a little bit of extra information. And the thing that we actually need is this part right here. Extended key usage, server auth. Curl was happy to accept our certificate just based on the trust from the root CA. Chrome didn't like it because it didn't have this extended key usage. So let's give it one real quick shot here to make this work. This is the part that I lost all those commands, but let's give it a shot. And if it doesn't work, we'll, you can just trust me on this. So we need something called the ext file. And then we need to tell it what, actually we might not need to do that. Let's just give it a try. Uh-huh. Let's start our server over because it had loaded the old certificate. And let's see if that did it. Refresh. Like I said, it might not work. Let's do a hard refresh here. Still doesn't seem to like it. But let's take a look at the certificate. Maybe it's not getting the right one. So you can see all this stuff. So if you want to explore certificates some, you don't have to do everything from the command line. That's more powerful. But this is actually kind of nice too. Just going up here and looking at the certificates. So if you trust me that eventually we could get that to work, that's essentially what happens. What I'll do is maybe we'll send a link out with something with all these commands that I ran here, and kind of get the. I'll give you the final command that actually made that work. So, any questions? I see one in chat. Interesting how in asymmetric encryption, a public key is used for encryption and the private key for decryption. But when it comes to digital certificates, that process is reversed. They meant for signature generation and validation. That was in the chat. When it comes to digital certificates, that process is reversed. I'm trying to understand exactly what that means. So when it comes to certificates, there is actually both of those things going on. We're using the public key and the private key. Hey, did that just go through? Oh no, sorry. Yeah, it still says not secure. I thought for a second it had gone through and changed. So in a certificate, is basically a way, it's kind of interesting. It's a way of signing a public key. So when we're signing that certificate, we're using the private key of the certificate authority and we're signing the public key of the subject of that certificate, and we're kind of linking that with that metadata. Usually it's a domain name. And so then that means that on the server, they can use, I can use that server's public key and encrypt data, send it to the server, and know that only that server can decrypt it. But I also am sure that that server is who it says it is, because I trust the certificate authority to tell me that that public key belongs to that server. So I don't know if that, I realize it wasn't a question, but if that kind of clarifies, Mehdi, your comment there. Great. He says it makes sense. And then right at the beginning of the talk, we had Riz said, before we end the talk, could you recommend a couple of learning resources, perhaps resources you've learned to learn on the job? I will include some links. Honestly, the one I got the most mileage and a lot of the examples came from was this. I'll put this in chat. This gist is how to create your own self-signed CA. So I'll put this here in the chat. Again, don't use this for production stuff, but I think it's great for learning. Now you'll see it has some extra stuff here that I kind of simplified, and then down in the comments is actually where I learned about this part about the where is it, further down, extended key usage, server off, right? So we actually needed that. So the comments are a great place. The other thing that I'll give you one other resource is there is a company called Small Step. And there is trying to find the link. If I can't find it in a moment, I'll just send it out after. But basically, I'm sorry, actually, this might be from another company. This might actually be from Cloudflare. But there's a super, super in-depth, long, took me like 30 minutes to read, just breakdown of everything TLS and a history, and you start to understand some of about why things are the way they are. So I will find that and I'll put the link in Slack because I didn't have it handy. That's what I was actually going to do in the last little bit before the talk rather than regenerating my commands there. What's the best way to differentiate? Here's a question from Tim. What's the best way to differentiate between public keys, private keys, and an unsigned key so you're linking them correctly? Was it the header data, as you mentioned, or file type being a dead giveaway? So the file type is not not always a giveaway because you can like have lots of different extensions on a file. But let's take a look at this. You can actually run this. Let's see what this does. I don't know. Let's look at a localhost.key. So local, it just says it's ASCII text. So that's not very helpful. Let's see if what it does on a certificate. It's probably going to say, oh, okay. So this is telling you that this is a PEM certificate, right? PEM is just an encoding format. There's other formats to encode the certificates that hold all the same data, just encoded in a different way. So there's something called PK12, so PKCS certificates and PK12 and ARN, I think that's the ARN1. There's there's all sorts of just kind of through building up layers in history in terms of how this came about. There's like it's really really confusing, um, all of these different things. One of the things you can do though usually is just if you look at it now, this doesn't actually mean anything, but it can give you an idea. Begin private key, right? And actually you can see if I go back to if I wanted to generate RSA, and remember I took out that. Okay, now I'm going to get a passphrase. Oh, I'm going to overwrite this key. So my demo is going to blow up here, but we're done anyway. Now, if I look at this key, see it says encrypted private key, right? And then if I look at the certificate, it says certificate. And then to get into like what it actually is, you're going to need to probably use that OpenSSL command, or I'm sure there's other tools that might be a little bit more user friendly than OpenSSL, um, where you can kind of look. So hopefully that answers your question, Tim. Any others? All right. Well, thank you everybody for coming. I know that was a lot of terminal time, but I actually kind of find it exciting to like unlock some things. So hopefully you did too. Please reach out on Slack if you have any more questions. I'll put together a like the slides and some of these other links. I'll find that other link and put that on Slack too. So thanks everybody.